Good morning, dear students. Let's start here the last chapter of this second semester, that is Insolation, chapter 12. And here we're going to see about the heating of the atmosphere. We're going to see the factors which affect the temperature distribution. So first of all, let's see what is the meaning of insolation. So insolation, the word insolation means the amount of heat intercepted by the earth is known as insolation. Now, as all of you know, that earth, the energy of the sun, that is the only source of the light and the heat energy for the different phenomena which occurs on the surface of the earth, and it is essential for the life. For as you can see, the sun, now all of you know, it is a star, and when you study about the sun and the other stars, so sun is not the biggest star, but it is the one of the medium sized star. So there are so many larger stars are there than the sun. But why then we see this sun so big there in the sky? Now, because the earth and all the planets are the family of the sun, that is the part of the solar system. They revolves around the sun, and the sun is the most nearest sun star, and so it just provides all the heat energy and the light energy. And the temperature, the surface temperature of usually the stars are 6000 degrees centigrade, so it's too much. And well, now this type, so let's see here first of all, and we're going to see the important things. Now usually the sun rays which enters the atmosphere, now there are different types. It can be classified into different types of rays, but the two most important rays are the infrared rays and the ultraviolet rays. Now here these infrared rays, they are largely absorbed by the atmosphere. Now why? Because if you find, they are the longer waves. They travel in a form of longer waves, while the ultraviolet rays, which usually are the shorter waves, what happens? They are being absorbed by the ozone layer in the atmosphere, and so it doesn't reaches to the earth's surface. So it only reaches when there is a thin layer of ozone layer. So it just passes it, and the ozone unable to absorb, then only some of the amount of the ultraviolet rays reaches to the earth's surface. Well, now next is the speed of these rays. The solar energy which travels in the form of rays, and the speed of this solar rays is 30,000 km per second, means in 1 second the solar rays, sun rays, it travels 30,000 km. So at this rate, when the rays from the sun to the earth, it takes about 8 minutes to reach to the earth, because sun is so far. Well, now what happens? This solar radiation, the rays of the sun, they usually provide 99.9% of the energy, that is in the form of heat energy usually, and also the light energy, right, to all the form of life on the earth. So now about the different planets, if you see, the earth actually, if already you have studied, the earth is neither too close like Mercury and Venus, nor it's very far like Jupiter, Saturn, Uranus, Neptune. So due to the very exact this distance from the sun, the earth receives the amount of heat which is required for the life. So this is a very unique thing, and already we have seen in the first chapter. Now, so usually what happens here, the sun's heat, when it enters in the atmosphere, so usually large amount of the sun's heat is reflected back, and some amount of the solar radiation is absorbed by the atmosphere and the things present in the atmosphere. So what happened? Not the full solar energy, but it's only about 45 to 49% solar energy reaches to the earth's surface. So what happens here? So for that, let's see here the heating of the atmosphere. This is a very important thing. Now this diagram, it just explains, it gives a very clear picture about the heating of the atmosphere. Now what happens, as you can see here, this arrow, it shows about the 100% of solar energy. This is 100% of solar energy which enters in the earth atmosphere. Out of 100%, 40% is reflected back into the space by the atmosphere and also by the ground. So 40% is reflected back. Now out of 60%, what happened, 15% is absorbed by the atmosphere, and then what happened, only 45% intercepted by this earth. So this 45% solar radiation which is intercepted by the earth's surface is known as insolation. So I think all of you have understood about the insolation. So usually we call it the sun's energy which enters in the atmosphere. So that is 100%, that is solar radiation. But as you can see in this diagram, 45 it is given, but in some book you can find this data, this percentage, actually it varies. So usually actually what happened, this is not the accurate 45% is intercepted, so it varies. So that varies between 45 to 49%. So between 45 to 49% this solar radiation which is intercepted by the earth's surface is known as insolation. Now what happens, this heat which is intercepted by the earth, now when the earth's surface it becomes hot, it starts radiating the heat back in the atmosphere. Now let's see here. Now usually you will find during the morning time the temperature usually is very low, but as the day progresses and during the noon time you can see the temperature just becomes very hot. Especially in the summer season you can find it's extremely hot, but even during the winter season in the afternoon it becomes warmer, while in the morning time you can find it's very cold. So how this temperature gets heated, let's see here. So in this heating of this atmosphere, there are the three processes you have studied, that is radiation, conduction and convection process. Usually you have studied in physics. Now these all three processes, it takes place in heating of the atmosphere. So how it takes place, let's see here. So first of all, the first effect is the radiation. The first process is radiation. As the earth's surface becomes hot, it starts radiating the heat back in the atmosphere. So the lower layer of the atmosphere becomes warmer. So what happens, the warm air rise up, cold air it comes down. So first of all, the first process is radiation. So by radiation, the atmosphere that is close to the earth's surface gets heated. Now when it becomes warm, it rises up, cold air comes down. So this is a process of convection. Now up to a certain height, what happens, the atmosphere gets heated by these two processes, radiation and convection. But what happens after that? After that, this heat is actually transferred from one layer to another, from there to another, and this is conduction. Now this whole thing actually I have explained you in the first chapter. I think first chapter or second chapter. So previously in the previous chapter already I have explained this thing. So by these three processes, convection, conduction and radiation, the atmosphere gets heated. So let's move to the now about the differential heating of land and water. Now usually you know that the land is a solid, water is a liquid, and there is a difference between the heating of the land, solid and the liquid. This is why what happened during the day, when the land it receives the sun rays, it absorbs the heat, and what happened, the land becomes hotter quicker than the water bodies like ocean and the rivers and the lake. Now this can be seen as the differential heating of the land and water. Now there is a, usually if you have studied in the physics, that the water has 5 times more heat capacity than the land. What is the meaning of heat capacity? Carrying heat capacity, conserving the heat capacity, means how much longer time any body contains the heat, that is known as the heat capacity, conserving that heat capacity. Now usually we will find the land, it becomes hot quicker, At the same time, it radiates the heat and becomes cooler also quicker than the water. But water, you will find the molecules are farther, and that's why when it absorbs the heat, it can keeps that warmth, that heat for a longer period of time. So both in heating of the water and also cooling of the water, it is slower than the land. And this is why you can find there is a quite different different heating property in the land and water. So this is what it is given here in your book. If you find here that quite different properties in absorption and radiation of heat by what thing? Land and water. Well, now because of this, what happened, all of you know, because of this differential heating of the land and water, you can find there is a one wind blows near the coastal areas, and what we call the sea breeze and the land breeze. So the whole sea breeze and land breeze, they develop because of the property of this thing, that is differential heating properties of the absorption and the radiation of heat by the land and water. Well, now let's move to the insolation. Already I explained you the incoming solar radiation. So the thing is, I already explained, the solar radiation that is intercepted by the earth is known as insolation. So you should be very careful, right? This is given here. Now let's move directly to the factors affecting the distribution of temperature. So here the first thing we're going to study the different factors. As you can find here, some factors are given here. Latitude, we'll see the altitude, distance from the sea, then the wind, ocean currents, clouds and the rainfall, the slope of the land, vegetation, nature of the soil. Now these are the different factors which affect the distribution of the rainfall. Now look here, first of all we are going to see about the latitude. Now when you see about the latitude, and for this I want to show you this map. Now here this is the earth surrounded by the atmosphere. So these are the rays. These rays falling on the equator, and these rays are falling on the higher latitude. And if you find here, this rays which is falling on equator, it travels less distance in the atmosphere, while the sun rays which are falling on the higher latitude, they travels longer distance within the atmosphere. So when the sun rays, they have to travel longer distance in the atmosphere, what happens? They become weak. This is why the slanting rays, they are very weak. And the higher latitude, you can find the temperature is cooler. As you move from equator towards pole, you will find temperature keeps on decreasing, and at the pole you will find it's very cold, freezing, right? But here you will find on equator, because as you can see, the sun rays travels the least distance in the atmosphere, and they are very vertical, and that's why they are very intense. And so the lower latitudes, the places on the lower latitudes means 0 to 20-30, they are much warmer. Temperature is quite hot. Next is the altitude. Now altitude means height. So as we go up the mountain, you climb up the mountain, you will find the temperature keeps on decreasing. So usually what happens, as we climb up with the altitude, with the height, usually the temperature decreases with the rate of 1 degree centigrade per 165 meter. Means at every 165 meter temperature, it falls by 1 degree centigrade. Now by this rate, usually what happens, if you take it in a kilometer, so after every 1 kilometer, temperature will fall to 6.4 degrees centigrade. So this rate is called normal lapse rate. Now the question arises, why this happens? Now you look here, this picture gives you a very clear picture. Now usually in the lower close to the earth's surface, the atmosphere is dense. But what happens, as you go up, the atmosphere becomes thinner and thinner. So with the higher altitude, the air becomes, it is written here, rarefaction. Rarefaction means it becomes thinner and thinner, and that's why temperature keeps on decreasing. So I hope all of you understood. Now one more factor for this you can note down, and another factor is the thing I have explained you in this map, in this picture, in this diagram. So I told you, when the sun rays enters in the atmosphere, it doesn't heat the atmosphere. So what happens? First of all, it is intercepted by the earth, and when the earth radiates the heat back, then the atmosphere gets heated. It means you can say that the atmosphere is not heated by the upward, by the sun rays entering in the atmosphere, but by the heat radiated by the earth's surface. Well, because of this principle, as the higher altitude, right, they are far, they are means higher, okay, and far from the earth's surface, and the heat travels from down to up, and that's why what happened, the temperature it's keeps on decreasing, right? So I hope all of you understood. Now let's see some more thing about the altitude. Another thing is the inversion of temperature. Now what do you mean by this inversion of temperature? Usually you know, all of you, that as we climb up the hill, means with the higher altitude temperature decreases, but sometimes what happens, in some special conditions the temperature, instead of decreasing, it increases. With the height, means with the altitude in the mountainous region, not everywhere, but in some special conditions the temperature increases, and this is called inversion of temperature. Inversion of temperature is just opposite of the normal lapse rate. Now usually where this inversion of temperature takes place, now usually what happens, now look here, this figure actually gives you a very clear picture. This is a valley. So what happened, during the night the cold air, it sinks down in the valley. Now in the valley usually the air is very calm, so it is quite cooler in the morning time, and usually these all things occurs in winter season. So in winter season, because it is too cold, and this very very cold wind, as it sinks down, the valley region becomes very very cold. But what happens on the mountain, the mountains are the first to receive the sun rays, and very quickly they becomes hot, means the air atmosphere around the mountain top, they becomes warmer in comparison to valley, because here you can find the air is very very calm, and it's still very very cold, so it takes time, right? So early in the morning we will find as the temperature top of the mountain is warmer, but in the valley it is very very cold. Now this thing you can experience in the some of the hill stations, especially in the valleys like Dehradun. When you visit there, you will find morning time it's very very cold, day it's very very hot, but during the night, as the night progresses, what happens, the temperature keeps on decreasing and it becomes very very cold after the midnight, and the morning time is very very cold. Well, next is the distance from the sea. Now all of you know, now here let me show you this figure. So usually what happens, if you'll find near the coastal area, because of the cold wind coming from the sea, that we call it sea breeze. So what happened, during the day the wind blows from the sea, during the night the wind blows from the land, and we call it sea breeze and land breeze. So because of this sea breeze and the land breeze which continuously blows here in the coastal areas, which maintains the temperature, and that's why coastal area you will find the temperature, means the weather is moderate, temperature is moderate, neither it's very hot, neither it's very cold. You can see the example of the Mumbai and Nagpur. Mumbai and Nagpur both are situated in Maharashtra. Mumbai is situated on the coast, Nagpur is in the interior part, and you will find Nagpur, you will find the climate is very very extreme, but in Mumbai you will find the climate is equable means it's moderate, day and night. Why? Because they are being influenced by the sea and the land breeze. This is why as you go farther from the sea, you will find that climatic condition becomes extreme. Extreme means in the cold countries it becomes cooler, in the tropical countries you will find that temperature keeps on becoming warmer. Well, now next is the ocean current. Already I explained you here in the previous chapter, the hydrosphere. I explained you there are two types of currents, the cold current and the warm current. When the current is cold, like here near Canada, the eastern coast, here you will find Labrador current. Because the current is cold, here the water body is cold, so the wind blowing over this water body, it becomes very cold, and here you will find this whole region in the eastern coast usually experience longer period of winter, and it's extremely very cold. Why? Because of the cold current. But at the same time, if you find here in Great Britain and the western coast of Europe, the coastal area of Europe, you will find, because if you find here there is a warm current. I explained you this Gulf Stream, as it is drifted, it is developed into known as the North Atlantic Drift, and after that you will find the branches. Norwegian current is the one branch of North Atlantic Drift, another comes down here. Now this is a warm current. Because of this warm current, the water body here is warm, and because the water body is warm, so the wind blowing over it, it also becomes warm, and this warm wind, it influences the climate of the coastal area, the west coastal region of Europe. And this is why you will find even in the winter season, extreme winter also, the temperature is not very cold. And this is why Britain and this coastal area of this Europe, the western Europe, this climate here is called British type of climate. Now this British type of climate is a very unique type of climate. Okay, so here this thing I have shown you to explain you that there are two currents, warm currents when the currents are cold, so you will find the climate of that region, you will find it is much cooler. But if the current is warm, you will find temperature is warmer. So the currents also affect the temperature distribution. Now next one is the wind. As all of you know, there are the two types of wind. One is the warm winds and the cold winds. Now in the coastal area you will find here onshore winds. Onshore winds means the wind which is coming on the shore, that is the sea breeze. The wind which blows from sea to land, that is sea breeze, are also called onshore winds, while the wind blowing from land to sea, that is the land breeze, are also called offshore winds. So usually what happens when the wind blows from sea to land? Now usually in the tropical region, the sea usually you will find it is warmer. As I already explained you about the differential heating of the land and water, so usually the water bodies are warmer than the land, both in the tropical region and the temperate region. So the wind blowing over these water bodies, it becomes warmer, and what happens when it makes the climate of the coastal area warmer, means if it is winter season, so it just makes it moderate, doesn't allow it to go very high, very cold. At the same time, these land breeze, what happen during the night, you will find what happen as the wind starts blowing from land to sea. So what happen, all the heat, usually during the daytime the land just absorbs too much heat, so all this heat energy is taken by this wind where? To the sea, and so all the heat is been radiated, taken by the wind. And that's why these two winds, onshore winds and the offshore winds, they just keeps the climatic condition in the coastal area moderate. So they are very important. Now there are different types of wind. There are the permanent wind, there are the local winds, you will study in the next chapter. Now so when the wind is hot, so what you will see, temperature also becomes very hot. The very good example in the northern India, North India, you can find in the summer season there is a very hot local wind blows, we call it Loo. So when the Loo starts blowing, especially that is in the month of April and May, so you can find temperature becomes extremely hot. But when the wind starts blowing from the mountains, foothills of mountains, means Himalayas, and slowly from December onwards, you will find the temperature drops down, and in the January it becomes very cold. So usually these winds are very important factor in modifying the temperature of the place. So today only up to here. Next session we will discuss about the cloud and the rainfall, then the slope of the land, then we will see about the different factors which affect the slope of the land, and then the vegetation and nature of the soil. So it's very very small, and then I will give you some more instruction also in the last video. And I have already uploaded all the notes in PDF form. All the notes is uploaded. You just check it, the last session of every chapter, and you will find the notes, and you just start writing it. And as you have to submit it, all the copies, try to just finish your work so that you get the marks, because some marks will be given to you, right? So all of you just finish your work and submit your copies. So all the best.